在管理交通路口时，也可以直接通过点击删除按钮。删除不需要操作。当交通高度与点零不符时，可以手动调整。点击选点位置后，在主视图选择任意调整标高。它是能将点云分割。
Okay, now you look at this here. Instead of now, instead of human identification one element by one element, now we can now utilize AI. It automatically recognizes this is wall, this is window, this is door. Okay, they can segregate it into different elements and then replace it with a BIM element. Okay, now you can see that they just pick on that point cloud and it becomes an BIM element. All right, this is amazing, done by Tsinghua. All right, now we now have a much quicker tools for us to do this conversion using AI identifications. Right? No need. Using AI now. 頭先嗰隻人手嘅，頭先嗰隻逐個畫嘅。唔係，佢呢啲佢應該 pick 落去個歷史度，即係唔使你再轉翻呢度開始呢個 end 佢自己度編排出嚟。箭最喐嗰隻人啦，但係佢啲起出嚟嘅結果 AI 起嘅。All right, now all of a sudden because of AI, there's a far less human work now. All right, it now becomes a pretty handy, useful tools for us. So you can see that Revit alone, it is not enough. You need to have other tools to help you to accomplish those tasks. Okay? Oh. All right, so that's on these elements in here. Okay, so far okay, right? So we keep on going. Okay, now let's take a look on. Okay, next thing I want to say automation, programming, this kind of thing first. Automation. So what's automation? To make it more efficient, we automate. Okay, what do we automate? Now, this is a BIM model. Okay, this is a BIM model. Okay, now it's from the design to construction. So what can we automate? From your experience, what can we automate? Huh? BQ? Oh, okay, yeah. This is relatively easy. Yes, you can do it. Fix it. Yeah, we write script to automate that. Okay. Now let me show you some. Let me show you some of my previous job, my previous experience, and show you how we can automate a certain thing. Okay, now let me give you first example. Okay, I'll give you architectural example, architecture example, structure example, MEP example, like this. Okay, now okay, now I ask you as architect. Now I got a site here in Central. This is sea view. We got a site. Okay, so I'm talking about design phase at the moment. So this design phase, what you see here, this building here, it is a design. It is not real. It is just a design, a concept design. So can I ask you as an architect, if you are given a site, given the top ratio, given the height restriction, site area, you have this basic information to come up with a design. How long will it take from an empty site to a design? Has all the joint. Joint means the plan elevation sections and then some analysis, the site view and this kind of thing. 風水嘢 ，OK 啊，風水 how long will it take？ 誒，what's the 啊？即係風水嘢就唔即係做 project，唔得嘅唔得啦，呢個生意唔得啦，嗱唔會，跟太耐，但係都風水嘢冇錢㗎，即係 when nothing to this about 2 weeks. 2 weeks, okay, a normal pay as a designer. Okay, we do simple calculation and some design like it. But if you present one option to the client, they will say, okay, why I spend so much money to engage you as a designer? You give me one option? Usually we can't. So we have to at least give them 3 options. The first meeting, we give them 3 options. So this is what it's got. So from one option takes 2 weeks, now we give them 3 options. So how long will it take? It won't be 3 times because some of the basic I would say, so 4 weeks, 5 weeks, something like that. Yeah, 4 weeks. 3 options. All right. You are right. So this is very typical for an architect to prepare a concept design, 3-4 weeks, 3 options, and then do a presentation. Normal. Okay, I'll show you this is option 1. This is something I did about 7-8 years ago. Option 1, option 2, option 3, 4, 5, 6. Every single option, they have drawings produced. They have quantity produced. They have the efficiency. They have different designs, different productions. What you have just seen here, 40 designs. I just gave you a reference. 1 design, 2 weeks. 3 designs, 4 weeks. You see 40 designs. How long will it take? 3 months. Really? Can we do it? Okay, another guess? Good guess? 1 month, can you do? 1 month is 4 weeks, right? We said 3-4 options to 1. Parametric, yeah. Yes. Any guess? Time. Not 4 months, and not 4 weeks. 1 day. 1 day. You have seen 40 designs produced with drawings, with calculations in 1 day. I did that in 1 day. Every 15 minutes, 1 design, all the drawings come out automatically. If you don't believe me, I see from your eyes, you don't believe me, right? I show you. We automate the process. This is using BIM. The right-hand side, this spaghetti. Our thinking process. We teach BIM how to design. BIM is not a tool to produce a design. We teach it how to design. We work with parameters. So the plot ratio is 15. What if I change the ratio? I change the information. All these are our thinking process. We note down the thinking process and let the computer do the design. This is how we use BIM. BIM is not a drafting tool only. It's a design tool. We can teach it. I'm not talking about AI. It's not AI. This is automation, not yet AI. This is something I did 7 years ago. So I'm using Revit. All you see here is automatically generated. It is automatically generated. It's not manually produced. So what I did as a designer, I just give it a shape. So with the shape, it calculates the area. So the total area divide the area, you calculate the number of floors. So every floor, what's the floor to floor ratio, and what's the floor to floor height? We have the floor to floor height, then we know the number of stairs. So number of stairs, the number of steps, we know how the area is. So from the area, we know what is the lift core. So how many of lifts we have rules of thumb. From this area, we know we kind of know how many columns are there. We kind of know what's the size of the column. So we have a column, we have a distance, we know how the size of the beam. So these are rules. We tell them the rules. So it produces for us. So what you see is all automatically produced. It is acting as a designer. So this is how we use BIM as a tool, design tool. It's not a drafting tool. So it's done 7 years ago. Now, since all you see here is automatic created based on the rules, because we have information. With the information, we can teach it how it work around with the rules. So with the curtain wall, so we wrap around with the curtain wall, and what's the size of the curtain panel? Now, this is scheduling. Since we got scheduling with a quantity, that means we know the cost if you have the unit price. So we know what the cost. So the next step, we produce drawings. So how to produce drawing? We ask it, we write the script. Every floor, we give me the plan. Every floor, give me ceiling plan. Give me the section. Give me the elevation. We teach the computer how to produce. So after 5 minutes, all the drawings produced, all the plans produced. So I create the sheets are ready. So with the title block to put in there, so every single floor the same position, all automatically done. I don't draw. I don't need to draw. As an architect, we don't draw. We design. Now I even let the computer to design. So the elevation, everything is here automatic. And then we put it into the site context, and then put it in the filter, and let it render. Every 15 minutes, we got a design. And 40 designs in one day. How can it compare to the manual project? All right, so this is automation. We automate the process. So now, if you don't know how to use Revit, these are all the commands. These are all the commands help you to draft things out. Not good enough. If you go to manage here, so the one where I was using Dynamo. So with Dynamo is an add-on to Revit, and we can let our thinking, our relationship, to tell it what relates to what. So we change the parameter, what is consequences. So we change the top ratio, and everything will change. These kind of rules. So now Dynamo is another area. If you are interested in learn and take courses and try to practice, there's a lot more to learn. It's not just how to build a model. Okay, BIM automation. Now this is one example. I'll show you another example. So this is an architectural example. I'll show you a structural example. Okay. Here's a housing authority example. Okay, now I saw the director. The director always come out to a conference and use this example because we work with them. This on the structural. Now we have the foundation guys here, foundation people here. Now look at this. If I draw a ground line here. Okay, now if I draw a ground line here, if this is ground, so I have a design. The piece of the building. So it is on this position. Now it has a foundation. So the foundation land on the rock, but the rock is not flat. So if I put in this position, all these different tiling will have different length. But if the design in this building move to another position, then it will have the different depth, different condition. All right. So the design about is the same, exactly the same. But I put in different locations, it will end up with different foundation design, different arrangement, and at the end, different cost. Okay, because it's not visible, what is the best design option for the foundation? Simple, the cheapest one. Right? The cheapest solution is my best solution. It's not visible. So, and if you think about this, how many foundation systems are there? how many variations are there? So large diameter ball power, for example, what is large diameter? What's the size? What's the spacing? What is the angle? What is the orientation? So there are a lot of variable you can change. Different position, different arrangement. So there are a lot of variables keep on changing. So if you ask a designer, if you ask a structural engineer, give me the best design. Okay, he'll give you three options. Okay, give you three options. Now this one, this good thing, bad thing, good thing, bad thing, right? Pros and cons. But you ask them which is cheapest. Okay, now this option B is the cheapest. Why? Out of the three, this is cheapest. But has he exhausted all the possibilities? No, because there's so many variables. Now, because he's a structural engineer, he's a designer, we trust his expertise. We trust his expertise. We thought that he must have given us the best result. But in reality, you know that, you and I know that, he is his best guess. But there may be cheaper option somewhere. Maybe. But we don't have the time, we don't have the resources, we do not exhaust every possibility. Because we are limited in time and resources. What if I put this building here, this is the ground condition. The positioning of everywhere, it triggers a different thinking, a different workflow. So all this workflow, we teach the computer to try and test we automate the process. So you can see that by the three dimension, variation X direction, or variation Y direction, or the angle, rotation. So every single variable will come up with different length, different configuration, and different cost. So instead of trying 3 options, give me 3,000 options. Let the computer run for 1 hour, 2 hours. You try for 3,000 options. So this is how we go. So put in different location with the different length, different configuration, and put all these variables. We automate the process. So all these variables, we change the different combination. It come up with a cost. Every single variation comes with a cost, and we choose the cheapest one. And it will run for 1 hour and give us 3,000 of them. And here's the cheapest one. This is how housing authority is using that for foundation design now. This is how we use BIM. Automation. Isn't it more efficient? So you build a model from scratch one by one. All right. So the thing is, do you know how to use things like this? Dynamo. This is another level of BIM. It's not just building a BIM model. It is automating the process. Okay. So we need to identify what are the variables, what are the possibilities. So we need to work with the engineers. How do they think? Okay, interpret their thinking into something. We can program it. We can lay out. It's not really a programming. It's a visual programming. The relationship. You change this, and what will be affected. You change this, what will be affected. This is basically repeating the human methodology, but it's just letting computer run in many trials.有啲講唔改咯，唔識得改邊度改？而家開始咪攞嚟，係真係攞嚟用。咁我哋同佢做呢個 exercise， 咁慳翻幾多 ？There's a lot of savings, human savings. Okay. Now this is one application. Let me show you another applications. All right, now we have structural model. So the structural model comes with rebars, and strictly speaking, every beam they need to produce a diagram, the rebar and the section. Basically, strictly speaking, is a long section showing the layout, and then it's the center one for the ending, and then the two shear. So basically, 4 details for one BIM. Okay, of course they will have similar, all right? So they simplify it using similar, but strictly speaking, every single one you should have it. Okay. So you can imagine there's a lot of work if you do it like this. When you have so many repetition, then why don't we automate it? So we do the same thing, typical thing. We write scripts, run the script. We use the thinking and how the engineer think, okay, and produce drawings. So I'll show you the result. So tell Revit, every single beam, you need to cut a long section and then 3 short sections and put it on a sheet. Okay, this is the result. So these are all automatic. And then every single one put in your drawing. So you have just done this exercise manually just for one. Now it's so many, it's all automatic. So it produces long section and 3 short sessions. Okay, now I'll show you the result. So all these are automatically produced, and then lay it out onto the sheets. Okay, I show you. Okay, this is the result. Automatically laid it out. Now I just do it as an exercise. I didn't actually make it perfect. You can see that it's outside of the box, the outside of the border here. Now, so when you come up to here and then come up to another sheet, and then another sheet. So all these are already produced. So once you got a model, you have all these deliverables. All right, so I'm just showing you some of the possibilities. So there are a lot more things you can do. All right, so that's on the structural automation. And how about MEP? MEP automation. Or MEP automation. Can we have MEP automation? Yeah. So how do you do all the alignments? How do you do the design of the layout of the MEP? It's a lot of work, a lot of coordination work. And when we say BIM, we always come up with a notion of clash detection. You heard about this term, right? Clash detection. For CCBC, this is one of your heaviest jobs. You do a lot of analysis, and you do a lot of clash detection and do the report, right? How to do it? How do we do this clash detection? That doesn't work. Very good. You have done it. So I've done it too, but I hate it. Why I hate it? I came up with a number of clash. So you are doing NH, right? You guys are doing NH. I was doing NH to the hospital. The first time I put it NH, the model for the clash detection, do you know how many was the result? Number of clashes. Make a guess. The first time I put it in there and run it, it runs about 10 hours, and the result was 600,000. 600,000 patches. What is the value? To me, no value, because I gave up. I cannot resolve 600,000. Come on. This to me is rubbish. It doesn't mean that the more you get, the better you got. That means you cannot handle it. Human effort, I cannot handle it. What is the point of giving me 600,000? It totally, to me, is meaningless because I cannot handle. in reality, there's no clash. There's no clash. So why is a clash? Why is a clash? Think about it. Why there's a clash? Let's take a look. Let's take a look. Okay. Now, yes, you say it's correct. So we do clash analysis using Navisworks. Okay. Now let's take a look on how Navisworks do things. Okay, Navisworks manage. The first thing, okay, why
bring in all the Revit models from the different disciplines here now first. Then I'll be able to do the clash detection and all the models. Bring in electrical, mechanical drawing, architecture.
Now he talked about clash detection. Bring in the Revit model in the Navisworks, and then okay, the first thing they put in got the architectural model, structural model, MEP model. The first thing they got is they do not align. They do not align. So how does Navisworks align them? It is crazy to me. They manually change the amount of rotation, amount of translation manually. So every design you change, you have to redo it. Wow, is it crazy? Wow, this is stupid. All right. So they change it and align it manually. Okay, until you got them aligned. And then they do a comparison. Okay, so they use a comparison of mechanical, okay, structural versus mechanical, two disciplines. I think most of you know how to do that. Okay, now fit in the computer. Okay, do a definition of tolerance. Hard clash, soft clash. Okay, so this is the result. So, okay, look at this. We run the test, and this is the result. The result is clash 1. So 2 elements, one red, one green. Now there's a clash there. So that's why this is the location of the clash. All right. So the number 2, clash number 2. Now all the clashes are real. So Navisworks has been doing a very good job, a real good job. Okay. By the rest, it is in transparent number 2. Okay. Now number 2 is another clash. So with this figure, this element and that element, and there's a clash there. So I do not deny the help. I do not deny the help with all this. And then what? And then you produce a clash report. So how do you produce a clash report? So again, this is the strength of Navisworks. And then, okay, this is clash number 13. Okay, now ask it to produce a report, HTML, and then, okay, give a run. Here we go. We have the screen capture automatically. Okay, now this is a classical result from Navisworks showing you clash 1 with the screen capture, with the location, and then with item 1, which is a wall. Item 2 is another element. So this is a real thing, it's a real thing, it's a real thing. So it is doing a very good job. You have seen this, right? You have seen it. 600,000 of this. Okay, let me ask you. Clash 1, clash 2, which one is more important? Clash 2, clash 3, which one is more important? How do you know? You have 600,000. We don't have time to resolve everything. All right, we would like to resolve the most critical one. Which one is most critical? No idea. So which one you resolve first? You resolve this? Is it this? How do you know there's a more important down there? How do you know? Never should just stop there. Finish. And leave all the problem for you. So do you know most of the designer, when you have a BIM coordination meeting, what do they comment on these BIM meetings? They said it's rubbish, no use. The BIM manager present the case like this is so trivial. That's not the real case because they cannot identify what is the real case. So we have 3 hours meeting. So you have not 60,000, 10,000, say 10,000 cars. How do you know which one is out of the 10,000, which is the most important one? You pick out and discuss it in the meeting. How do you know? You don't, because Amazon is not doing this. So what's the value? Okay, now I don't talk about this now. Probably I'll come back to this because I have some other automation. But let me step back. What are we doing here? We are doing something called clash detection. Why is there a clash detection? Reality, there's no clash. Why there's a clash detection? Why there's a clash? Huh? Why does someone overlap? Because I'm the designer, I don't care about you. You are a designer, you don't care about me. I just do my own thing, you do your own thing. So when we all work together, we put it together, of course there are clashes because we don't talk. We don't communicate. We don't care. Right? So what clash detection is doing is, okay, I accept the fact that you don't talk. I tell you the problem. But it is not addressing the real issue. The real issue, you should talk. If I have my design here, I got a pipe here. Why you come and hit my pipe? Why you come and hit my pipe? You should find another way because I'm already there. It is because you don't mind my design, so you keep on doing your thing. Of course, a clash. So now it's not addressing the issue at all. It's just giving you the clash, which is not going to do us any help at all. Think about this, right? So in that case, the real issue is we should care about the design. We should care about how the people are or work as a team. Now, having said that, the reason why I don't like Namsa is it is indifferent, 無差別地 give you a report. It doesn't have a priority. It does not have a priority. Whatever the clash, this is give you a report. So you end up with 600,000 clashes. In fact, most of them you can ignore. Let me give you an example. Tell me, if you have 3 things, column, beam, slab, you have 3 things. That's the structure. Then you have a 25 mm pipe. You have to run through this pipe. Run through this pipe through these 3 things. Which one is more difficult? On number 25, you say 50 mm, or even 100 mm. A pipe run through these 3 things. Column, beam, slab. Which one is more difficult? Why? It is structural. You may not allow you to run through it. Okay, then next one. Why? You're doing structural. You got top layer of the bar, bottom layer of bar, slab, 100. So what? To make a hole there. We professionally, there's a differentiation. There's a hierarchy. We know that. This guy doesn't know. Whatever class will give you a report. So we have a hierarchy, but the software did not address this hierarchy. This is how AutoCAD behave. They don't care. So it is not working with the industry. It is just whatever your class is just giving you a report. So what? Okay. Now, if you put this into account, so I show you about 10 years ago, I worked with Hip Hing and on one project. So of course, there's a beam model. Now I have two phases. This is phase one. So I have a structural model. Now, let me ask you a stupid question. Let me ask you a stupid question. If you have a plant room here, if you have a room here, you need to run a air condition from the plant room to the room. Of course, we know that, right? So we have a plant room, give out cool air to serve this room here. And from the engineering design point of view, you can size it. So you know this area, you know the use, then you can calculate the cooling load. So you need to have a certain size of the duct to produce certain size of cool air, so they can transfer from A to B here. We know that. So that means we know how big the size the duct should be. Of course, it keeps on changing, all right? But in a simple world, so you know the size. You know the sizes from A to B. So the simple direct answer is run a straight line, A to B, then it's finished. Okay? But reality is not like that. There's a lot of things in between. You cannot run a straight line because of the corridor, because the headroom, because of whatsoever. So to run a duct from A to B, so what are the obstacles? Okay, let me come back to step one step back. When we say now you are running different surfaces, you have air condition, you have air duct, you have pump drain, you have fire, you have electrical. If you were to design to run it, which one is the first one you should consider? Why? It is the biggest one, the most funky. You consider air conditioning first. What's next? Why? The four. It is very hard to deal with because you have to align the four. You something in between. You can't do it. Four. Next one. Why? I would say personally, I would say you have to go with the last one. Fine surfaces will be the third one. Because electrical, you can go up and down. There's no limitation at all. You can do whatever length and whatever angle, right? But okay. Now, what I'm trying to say, we have priorities. We have hierarchies. So let's say the duct. If you want to run a duct from here to here, so the first thing I would like to run a duct is most chunky. So what are the obstacles? So one is A to B. What is the obstacles? So the obstacle is I must be above the ceiling. The architect defines the ceiling. If I don't have an opening on the bottom of the beam, the size of beam is my limitation. I need to fit in to find a place between the ceiling and the bottom of the beam. So I first run my duct. So my obstacle is ceiling and beam. So if I run that beam, the next one, what? I finish running then I run the pipe. My obstacle is ceiling, beam, and duct. Right? And then the further you come down, the more the focus in front becomes your obstacles. Right? If I know how much space I have, and I know my own size, I may be able to figure out how I can find the space to run my duct. So phase one, I don't show you the process in between. So the result is this. This is my result. In between, we wrote software. We wrote software to detect the space. So what you see is look like a heat map. It is not a heat map, it's a space map. Space map means the space between above ceiling and below beam. So the more red, there's less space. The more blue, more space. So if I run from here to here, and I know my own size, I'm trying to find a space I can mingle the shortest distance without hitting the below ceiling and above beam. So if I run my first pipe, and then a second pipe or second pipe, then my first pipe with my obstacle, I try to avoid it. Instead of clash detection, I use clash avoidance. Avoid the clash. Then there's no need to do the clash detection. Clash avoidance. Now, so this is step one. So this is my initial detection. No surfaces, just ceiling and beam. Then after I run the first pipe, and then I run the software again, then it becomes a different heat map. So the leftover space for my second pipe, and then run again the third pipe, and run again, keep on running this. So I'm doing a clash avoidance approach. There's no clash. Now this is my principle. So I worked about 10 years ago. I worked with this heat map, the level of space. The next phase is I know how to do it. I didn't have the money to do it before. So because we finished this phase one and we don't know cash. Okay, now have you heard about A-star algorithm? Okay, no. Okay, have you heard about a computer game? A mice running in a maze. A mice in a maze. 老鼠走埋高. You put a mice inside a maze, it will automatically come out. How? Young lady, young guys like this, you don't know what I'm talking about. So that was a computer game in 1960 or 70s, right? Okay, I'll show you. A-star algorithm. Okay, look at this. Start, end. Start, end, some obstacle in between. So the red and green, they're trying to detect. And then the blue is the shortest distance. It works out automatically. The shortest distance from A to B, not hitting the obstacle. Isn't it the same problem we just described? From A to B without hitting the obstacles. So that's avoid the clash. And it's been around 1960s. The algorithm is around for 80 years, 60 years in the game industry. They work out this, but we have the same problem and we don't work out this. We use manual every single line, we draw, and then we don't care, and then we have clash detection. Someone worked out the solution and we did not make use of it. Same problem. Is it the same problem? So I take this algorithm on board until recently. I start off another try. Let me show you. Okay, I'm making you the gaming engine. So the ceiling and the beam and the different E&M here, they're obstacles. So from start to end, I know where my prime room is, there's a start. I know which room I want to go to, the end. So now I'm using a pipe. I'm doing a new pipe for 40 mm. Look, it is detecting from A to B, shortest distance without hitting the object. So this is clash avoidance. It won't have any clash. You don't need to go to clash detection. This is clash avoidance. Why can't we think BIM this way? You see that? It is trying, when we detect there's obstacle, they try to get around with it. So what is clash detection? There's no clash. Clash avoidance. Right? Now, I have not completely resolved it. Okay, because this kind of fitting doesn't exist. All right, it's just go to whatever angle, the shortest distance. I haven't had the time or money to actually refine the algorithm to constrain it into a certain, fitting, so that I can know the, go in a certain way. Now, this is the target. This is someone start the target, bingo, done, and that's it. Shall we use this methodology to work on our design? Why you do clash detection? Clash avoidance. Automation to resolve our problem. We got all these problems. All right. Now I'm using, well, it doesn't matter how this is our dimension. Okay, it's just a platform wherever we write the software and talk. So you have the idea. You now BIM, it is a platform you can actually customize it, automate it to do all these wonderful things. Okay, it can really help us in our industry. Any comments? Yeah. Yes, I know. So good idea. Yeah. So it's a different role. I mean, so you think about it, technology changed the workflow. It changed the way how you as a main contractor or subcontractor work together. All right. In fact, it helped everybody. Right? It helped everybody. It resolved all these huge problems. But there's a change. There has to be a change. That's the most. It's far more difficult than the technical solution. Right? Changing people is far more difficult. Yeah. Yeah. All right. So I want you to expose to you, right? Those are possibilities in BIM. Okay. We even I can do it like this, right? I'm not programming. I'm over here. So I'm sure there's a lot of area you can think about that in your area using BIM as a technology to resolve that. All right. Okay, since you're here, let me take you through another aspect on this. Now, this is an extreme auto routing, right? This auto routing that resolve all the facts. But if I step back, let me talk about the network. I just let's talk about the clash detection a little bit. So the clash detection in here, the BIM we're talking about 3D coordination. So when we say clash detection, is actually on this 3D coordination. So you coordinate among different disciplines. Now it's mandatory. So when you say you have 4 contractors, you have MAC, 5 services, they all do their own design. They have the model. So now as a BIM contractor, you combine it together. So you are doing this 3D coordination. All right. So as a contractor, you do this. As a designer, you do this. Now, we said that we are using Navisworks to do it. Let us do a exercise. Okay. Go to Revit here. Okay, call up this file. Got this file. Did I do this exercise with you? The clash one already? 有冇做過呢個 exercise？ 叫你睇 criteria， 我唔記得咗添，呢班有冇講過？冇俾嚇。如果我重複你話俾我聽下，我唔記得呢個 exercise 有冇講過俾你聽。Okay, now I want you to go to floor plan. there's a grid line, grid line E, on my ground floor grid line E. You can see there are 2 columns there. So these 2 columns, can you tell me what is the size of the column? I did ask you this question before, right? Okay. All right, can you tell me the size of this column? What is the size of that column? Anyone? 300 mm. Okay, fine. Now, remember this is an architectural model. Architects do not know how to do calculation. I do not know how to calculate, right? So as an architect, I know there's a column here. But I do not know the size. I just put a column there, 300 mm. Whether it is good enough or big enough or small or small enough, I don't know. Okay? I need to give that to the structural engineer, and he is the expert to do the calculation, and he will tell me. All right, but I know that I know roughly I need a column there. Okay, now this is number 1 I want you to look at. Number 2, I want you to look at on the top left hand corner, there's a cafeteria. And at the bottom of the cafeteria, there's a wall. And above the wall, there are 2 columns there. Okay, anything wrong with the column? Anything special with the wall and the column? Architecturally, it's fine. It's an expression. I wanted there's a 1 element here, 2 isolated columns. It's fine. Actually, for this problem, from this one, I don't see any problem. I don't see any problem. This is just architectural expression. Okay, number 3, I want you to look at in the front door, there's a canopy. And there are 4 columns holding the canopy, holding up the canopy. Okay, so they have a concrete base and then expose the eye column for putting the canopy. Okay, nothing wrong. Okay, this is the architectural design. Number 4, to the other side of the canopy. So it's different. So they only have 2 columns instead of 4. So they have a cantilever thing on above, all right, cantilever out. I don't comment on the design. This the architect wants like that. Fine. Okay, but what I know is 4 columns at the bottom, 2 columns above. All right. So I asked you to look at these 4 areas. Now, in here, if I look at 3D, so this is 4 columns, and then the other side, okay, 2 columns in here. All right. Now, if you look at the bottom, there's nothing, because this architectural model. Architects don't concern about anything invisible. Okay, so this is architectural model. Now, if you can recall last time, we look at the structural model. Okay, you don't need to open. Let me open for you. Now, this structural model, RST. Okay. Okay, now this project here. Now you can see that they are the same project. This is architectural model, this is structural model. The structural model have foundation, have piling and power cap, have BIM, BIM, right? So architectural model does not have the foundation. They does not have. Okay, now you see the difference. Now you know that when I'm an architect, I do this architectural design, I don't know the sign. So I give the architectural model to the software engineer. He did the calculation and he built a structural model. Now, once he built the structural model, he will give me back his model so that I need to incorporate these design in my design in here. Okay, now this is something I want you to do right now. You input it back into your architectural model. Let me close this off. Now, what I want you to do is actually to do a insert and link Revit. You link the structural model back. Let me find the path for you first. Okay, now here is the path. So you insert from the architectural model, you insert from the C drive program file Autodesk to for example. Okay. The only exception is this machine here. This machine here is C drive. Yours is C drive. The reference file is C drive. Okay, please. Okay, now insert this. So you insert it back, find this sample. Okay, Revit 2024 samples. STR. So samples, you link the RST, Revit structure file. Okay, now just click OK. It seems nothing changed, but if you look at the bottom, so now you can see that it's actually the structural model is now inside the architectural model. All right. So now you've got a live architectural file, and then you've got linked structural file. Okay, we call it link file. Just like AutoCAD, we have X references. All right, the same thing. Now, once you see the bottom, then you know you have done this successfully. Now, if you look back in the floor plan, I asked you to look at 4 things. Now look at grid line E. Now it looks different. Grid line E, you have 2 circles. That means I have 300 columns from the architect, and then after the structural engineer do the calculation, it is not enough. It will collapse. So he built a bigger column. So what is the size of the bigger column? What is the size? 450. How do you do that? You cannot measure it. How do you measure it? Okay, the trick is you need to press tab, and then click. Okay, close to the tab and then click. So you know that it is 450 column. Now 300 was my thought. I do not know how to calculate. Now the result is 450. All right. So now I understand. Okay, of course I accept the fact that it needs to be bigger. Otherwise, it collapse. I have no choice. I need to accept this. Now, this is number 1 thing I want you to look at. The second thing, if you go to the cafeteria, go to that wall, what happened? Go for cafeteria. What happened? It's a clash. Right? It's a clash. It wasn't a problem before because I thought that I'm okay. In fact, after the calculation, I'm not okay. And there's a clash. Okay, what do we need to do? Someone need to move. Someone need to change. Who is going to change? No, I'm an architect. So I need to change. Okay, I'm not gonna, he's going to change. Okay, someone need to change. Okay, now this is my second point. Look at number 3 point. Look at the canopy. I'm the architect. I need 4 columns. I don't know the size. How come a structural engineer? I know it's bigger. Why is it in a different location? He changed my design. you see that? It changed my design. I don't know why the reason why is that. He changed my design. Okay. For no reason. Look at the 4th one, the other side of the canopy. I have 2 columns with a cantilever. I don't know why he put 3 columns, no cantilever. It completely changed the design. What am I doing here? I'm doing coordination. Right? We are coordinating between 2 different parties. We need to talk. He's going to change, not me, right? He's going to change. So we initiate the dialogue. Now, bear in mind, I'm using Revit. He's using Revit. So that I can easily come together. But I'm using Revit. He's using Tekla. I cannot do this. All right. Now, let me ask you a question. You can see the difference between architectural design and structural design right now. In number 2, you see there's a clash in here. Why you see there's a clash? Well, I asked you to do that. I asked you to do this. If you do not have my instruction, if you are given 2 drawings, one is architectural, one is structural, you don't know where you cut back. What will you do? No, cat. I'm doing cat. In cat situation, if these are cat, architectural cat, DWG, and then structural DWG, what will you do? One in red, one in green. You overlay them together, and then what? And you look at it by eye. Every inches, you look at the difference by eye, manually. That's what we do. So you have hundreds or thousands of drawings doing this, and you look at it one by one by eye. So we are the most inefficient industry. How do we improve it? So instead of we look at by eye here, we do a collaborate. We are now collaborate. Collaborate, interference check. And you can run an interference check. So now you can see that we have 2 columns here. Both are the same at the moment because they are all current project. But you should not be doing this. You should be one current project, the other one is structure. Okay. So these are the elements which is live. These are the elements that's from the link file. So I was comparing the architectural walls and structural columns. Right? In my cafeteria, I'm comparing the architectural wall and structural columns. How long will that take? If you're doing CAD, you're doing red and green, and you look at by eye, how much time that takes you to go through all the drawings? Now with BIM, you specify the difference and you hit OK, how much time? It takes 1 second. Now there are 5 clashes in here. So if I open it up, all this plus sign, every clash, it must consist of at least 2 elements. If you look at the number 3 clash, if I highlight the wall, it shows me this is the architectural wall, the number 3, and then clash with the column, which is this one here. All right, so you know where it is, you know what element that is, element 1, element 2, and the location. Now, Revit, without knowledge work, you can already do this clash detection. So if you go to, say, the first one, so where is it? If you go to show, not a good view. Go to show again. Oh, come on. You have a wall here, vertical wall, and you have a column. exactly the same clash, exactly the same type of clash, but at a different location. And you do not need to look at it by eye. So this is when you do a BIM model as a BIM manager, clash detection is something, is a fundamental function. It's a fundamental thing. Even without Navis work, you can do it here. Okay. Now, but hang on. Why we spend 1 second comparing architectural wall and structural column? When you were given two files, how do you know which one is which? How do you know which has clash? So if I cancel it, if I do again, collaborate, interference check again. So I have these two. How do you know it is wall and column? Why is not ceiling and floor, ceiling and column, ceiling and foundation, ceiling plate? So 1 to 1, 1 to 2, 1 to 3, and then 2 to 1, 2 to 3, 2 to 4, then 3 to 1, 3 to 2, 3. It's a matrix, isn't it? So this is called a clash matrix. So you don't know which one is gonna clash. You don't know. So what if you don't know, you select all. You select all. So that will run through 1 to 1, 1 to 2, 1 to 3, 2 to 1, 2 to 2, 2 to 3. Now, a small project like this, you select all the object and ask you to compare. How long will it take? Or let's see. I click OK. 1 second, 2 seconds, 3, 4, 5, 6, 6 seconds. 6 seconds. And how many of these? I don't know. Maybe 200, 300. Every single one, without any effort, is a clash. Straightforward. So clash detection is not something great. It's simple. And you don't need to do anything. Just press 2 buttons and here you go. You got hundreds and hundreds of clash in seconds. But the point is, that is not your solution. It gives you the problem. And what's the solution? Your problem, right? The software is not going to resolve your problem. It just tells you the problem. So what is value? Now, no one will use Revit to do this because you cannot save this. So you do this and then go for lunch and then you don't know where you're up to. So people use Navisworks. Okay, but clash there is nothing big. It's simple. The thing is, everybody can do this clash detection without understanding whether you got a solution or whether it's important or not. They do not have priority. That is a problem. So clash detection is no big deal. Just press a button. All right. So if you look at the contract, BIM manager, if you look at the contract, I'll tell you a horrible thing. So see how the contract writes. How's the contract written? Someone wrote this from the government. Okay, so this is particular spec. You see this version. Objective. Deliver a clash-free design. This is absolutely crazy. So detect a clash is simple. How much time you need to resolve one clash? So this is spec written in ASD about 4 or 5 years ago. So-called a clash-free design. It doesn't exist. Why? Let me tell you a situation. You have a BIM 800 deep. You have a fire pipe 25 mm thick. Do you need to pass? If you need to pass through a BIM, Is it possible? 800 to 25 mm. Without structural engineer calculation, even without a calculation, I know this possible. Because your rebar is 100 mm. Without cutting any rebar, you make a hole, and it is absolutely possible. No need to have calculation, right? If that's allowable physically or structurally, do you think that the structural engineer who build the structural model will be so responsible to make a hole in their model so that you pass through it and so there's no clash? 100% sure they won't do that. So what that means is there are hundreds of clashes there in the model. It's already there. There's no one will clear it because I know that on site you can be possible. I won't take the time and resources to make a hole in the beam so that you can pass through it. So that clash free doesn't exist, right? It never exists. There's no such thing as called clash-free design. It won't exist. So I keep on complaining to them actually. So the latest version, they take this away now. they know that it doesn't exist. So if you look at the later version, so BIM manager, what do you need to do? You review and analyze by using different software, such as clash detection and resolve the clash. Now, it didn't say clash-free design anymore. So you need to do the clash detection and help to resolve the clash. Report any clash conflict. Report it. So you find the clash, you report the clash. Who resolved the clash? Should that be the manager? No, you're not a designer. Right? So resolve the clash is not it's not the BIM manager liability. It should be the designer or the supplier contractor, subcontractor. All right. So they should be the one who do it. It's not the BIM manager. So that's why, okay. So that's why all these clause in here, it is not addressing to the core problem. The core problem, who is resolving the clash? If we do not care about others. So clash detection to me is not the answer. Clash avoidance is the answer. Okay, you see how the contract is written. The contract is written according to the software. The software can only do clash detection. The software cannot do clash avoidance. So this is how the contract is written. Now, having said that, that means the BIM manager is simple because you only need to press the button without the need to resolve it. So report the clash. How do you report the clash? How do you report the clash? Think about this. So if you do in Revit, so you need to screen cap where it is, and then you have to write the location and which element 1, which element 2. One page A4, you report one clash, and then you have 600,000 to write. How can you produce this report? Even though you can produce it, how much time you produce 300 clashes? 5 seconds, right? How much time you spend to produce a report? Now, even though you can produce a report, it is not as a BIM manager to resolve it. You give it back to the designer, you give it back to the subcontractor, right? So I keep telling the architect, keep telling the designer, if on every Monday the BIM manager gives you a report, that report consists of tens of thousands of pages put on table, and you have 1 week to resolve. What will you do? What will you do? If every Monday on your table one page is one clash. You got 100 pages on the table. What will you do? I don't know about you. I trash it. You cannot resolve it. Come on. You cannot resolve it. Right? So what's the point of doing the clash detection and report it? You just give you a number. What's the value of it? Right. So I show you how I think about this. You have a clash. What Navisworks has been doing is clash detection. What is doing clash reporting. And Navisworks just stop here. That's it. Detect it. Yes. Detect it and report it. Finish. Right? What it doesn't do is to prioritize it. What it doesn't do is to visualize the clash. It just gives you a report. What it doesn't do is to eliminate the clash. Priority prioritization. Okay. So what Navisworks do is just doing 2, whereas you should have 5 steps. Agree? So finding a problem is not a solution. You want to eliminate all the clashes. What is the best clash report in the world? What is the best clash report in the world? CCBC. Huh? The best case, the best clash report. The best clash report in the world is 0 clash. You want to see it, we see a report, there's no clash. All right? It's not you want to see I got 10,000 or 10 million. It's 0 clash, the best clash report ever. All right? So doing Navisworks, giving you the total number. What's the deal? Okay, now let me show you. Inside of Navisworks, I show you another approach. Here. No, don't worry. Don't worry. It won't up to that detail. Okay, now this is something I did. Detection, Navisworks. Reporting, Navisworks. Red and green. Okay, what's next? Prioritization. We prioritize the clashes. So we do not have the ability to resolve all the clash. So I give it a rating. Score 1 from 10 to 100. Score 2, 10 to 100. And then when they clash, it's a multiplier of these two clashes. Then visualize it. Where are the clash? Instead of looking at the report, we can look at it from the model. See the number of clashes here. Looking at the report, so what? Okay, so visualize the clash. Okay, because of prioritization. So you can see that this times this give me a range of the most important one is 100. 100 times 100 is 10,000. 10 times 10 is 100. So the range from 10,000 to 100. So the higher the mark, the more important that is. So you can see that it created hash markers. So you can see that the bigger the ball, the more serious the clash. So I do not have the time to resolve all the clashes. So get the biggest ball and resolve the area. Now I'm visualizing the clash in the model. Unlike now it's work, just give you a report. You don't know where it is. Huh? Yeah. That's stupid. All right, so you can, so at the end of the day, it is elimination. You can see that the clash markers here, we actually change it in different color. So the red one is newly found, the green one has been resolved, the yellow one is something we cannot resolve immediately. It depends on some calculation, some other decision. So if we rank it, so can you see that what I'm doing here? It is to use the existing system to build on it to enhance the overall. This is clash issue. Now, not talking about clash avoidance, even the clash. See how never struggle is just give you the report. That's it. It's not addressing really the issue. Yes, of course, you got that. Further, yeah, prioritize it. Yes. So what I'm just exposing you as BIM manager, right? So there are a lot of other steps you can go through, and just having know how to use Navigator is not enough.冇所謂嘅，即係睇下即係你見到前面點行嘅，呢個唔會啱落，嗰時我即係真係成鋪咁鋪嘅。可以好多年前嘅嘢，今日邊個今日先做自己係未得，即係會遲咗可能要點得。我就分入我自己，但係即係我想講就係好多 area 邊唔係淨係你今日話俾你聽俾個 model， 今日話俾你聽翻佢聽，呢啲係 Autodesk 話俾你聽，只係佢話俾你聽，呢啲係 sales pitch 嚟㗎，你 marketing 嘅 sales pitch 嚟㗎。OK， 真正唔幫唔到我哋做緊，我哋要解決個問題啊嘛，呢個先係我哋，佢係冇做到㗎。係啊，佢有冇跑啊？係啊，係好多思維，即係好多嘢可以諗可以做，但係冇做到啊。So as a BIM manager, you should think about this now. These are just examples, right? This is about automation. So this is on the automation side. A lot of areas you can improve your workflow. Okay, I'm just showing you this example. From mobile navigation from mobile navigation to broadcast to develop develop the format. 即係唔一定要 navigation， 唔係淨係得周去 navigation， 同一好多收嘅都。咁只不過大家都用 navigation， 但係點解咧？因為佢係最叻嘅 market， 因為佢最 proactive 嘅 marketing， 就 Autodesk。Now you see that actually I'm now having different core communities together. I'm talking about software, but at the same time, I'm already talking about the BIM use. All right, so this is core community number 3 on the BIM use. So I'm kind of integrating them together so that you understand the whole picture. Okay, now let's continue. Programming automation, things like that. Now, programming automation, API. What's this word? What's API? Yes, what is it? Why is a computer work? I mean, it's not of our industry. This work for not for for us. It's a computer thing, computer industry thing. Why we need to learn, or I shouldn't say learn. Why do we need to know about it? Exactly. Yes. Very good. I appreciate that. So because you as a BIM manager, we are dealing with a lot of different software. So we are talking about, when we talk about BIM, we talk about information. That information can only be processed by different software. And we need to link them together to make it into one project, to make it work for one project. The thing is, two software do not talk to each other. So how do we break this barrier? So anyone do not know about this API? Well, I did not know about this term 4 or 5 years ago. Okay, I do not have how it works, but now I'm very clear. So API stands for Application Protocol Interface. Now, take it a very simple example. You are looking at my computer, my laptop here. So my laptop does not have a thermometer. Here is 33 degrees. Why is that my computer show you is now 33 degrees? It is information. Where is this information? Hong Kong Observatory. So how come my computer can get a live information from HKO Observatory and display 33 degrees? This is the information. This information not from this computer. It is from somewhere. So how come I can get that information? So this 23 degree is coming from a software. The software is inside Hong Kong Observatory. Okay. Now what my computer does is actually fire a request through internet, fire a request to their software, not on their door. Not on their door. I want to know the temperature. So they open up the door and let me in. Look at my request. I want to know the temperature and time. So they give me these two pieces of information. So I get this information and display on the screen. So this information, it is through another software. Why I can get in there? Because they gave out the API. It's the door. If they shut the door, I cannot get the information. So if they don't give me the API, we cannot get it. So API is a door of a software to let you go inside, to let other people go inside. So the reason why you need to know this, because we are dealing with a lot of this software as a BIM manager, because no one software can resolve all the problems. So you need to look at many different software and to link up the data. So you need to see whether they have API, how to link them. So even though it's a computer works, but we as a BIM manager, we need to do that. Now, so this becomes a very different question. Traditionally, we don't care, we don't know about the programming. Traditionally, we are doing construction, we are doing design. But now when we talk about BIM, this is not enough. We need to have programming people joining us. Okay, now I told you I'm an architect and this architect. I have 6 full-time programmers. I really have programmers. So all these I show you was done by a programmer, not construction people, programmers. So the question to you, does your company have programmers? I think you do. Yeah. So that's why it's not pure construction now. We need to integrate the IT people to join the team because we are dealing with digital information. If you do not know how to write Dynamo, you do not know how to write the scripting, so you cannot perform a lot